A ball is dropped from rest off a cliff. A, what's the velocity after 5 seconds? And B, how far did it travel after 5 seconds? So I'm going to solve this physics problem for you. I'm going to go through all the details. And I'm going to explain everything. And I got this problem from somewhere else. So the other problem did talk about speed versus velocity and distance versus displacement. I'm going to address that too. Everything's going to be made clear. I'm not going to skip any steps. Okay, so let's start from scratch. If I drop that ball off a cliff, the very first thing I want to think about is, well, what forces are acting on it? Once your hand loses contact with the ball, the only force on it is the downward gravitational force. Now, this probably isn't what you want to look at this problem. You may want to say, I know the acceleration, but I'm going to tell you how to get that acceleration. So we can use Newton's second law. It looks like this. F net is mass times acceleration. And in the y direction, let's call this let's call that x. Let's call this y. In the y direction, I can write, this is a vector problem, right? Vector equals vector. I can write this as two equations. One in the x direction, F net in the x direction is going to be equal to the net force in the x direction, which is 0. And that's going to be mass times acceleration in the x direction. But nothing moves in the x direction anyway, so no one really cares about that. And then I can write it in the y direction. F net in the y direction is equal to the force in the y direction is going to be negative mg. And remember, g is the constant, 9.8 meters per second squared. And that's going to be equal to mass times acceleration in the y direction. So you see here the mass cancels. We don't need the mass. They don't give the mass. But I do get the acceleration in the y direction. Ay is negative g. Okay, so now I know that, and I want to find how fast it's going after 5 seconds. Here we're going to use, now that we have the acceleration, and I'm going to drop the y because we're only dealing with this in the y motion. I can drop the y, and I can use the definition of acceleration in the y direction. A is defined as the change in velocity with respect to the change in time. And that's going to, I can write that as, this is v1, 0, v2, I don't know. So whenever we write delta, we mean change in. So I can write this as v2 minus v1 over delta t. And again, I'm dropping the y. We're only dealing with the y direction, but this is technically the y velocity. And I know what this acceleration is. Negative g. Now, what do I want to solve for in this equation? I want to solve for v2. And I'm going to do that before I plug in any numbers. So I'm going to multiply both sides by delta t, and I get v2 minus v1 is negative g delta t. Now I can add v1 to both sides. v2 equals v1, no, minus g delta t. Now I can plug in my stuff. So I know the time interval is 5 seconds, and I know g is 9.8, and I know v1 is 0. So I get 0. I'm going to leave off the units for now, just to make it clear, minus 9.8 times 5. And that will get, and notice this is 9.8 meters per second squared times 5 seconds. It does give me meters per second. Let's take out our calculator, on, clear, and I'm going to leave off the negative to say 9.8 times 5 equals, and you can see that's 49. 49 meters per second, which is actually pretty fast. Okay. Now let's just go ahead and talk about, I'm sorry, negative. Right? I have the negative. And this is the y velocity. So it's v2y. And that is important. So let's go ahead and talk about the difference between speed and velocity. So velocity is a vector. We really write this as, I could really write this v as 0, there's a jet outside, minus 49 y hat, and that will be in meters per second. So it has x and y components. If I just take the magnitude of that, that would be the speed. So the speed is the magnitude of the velocity, and that would just be 49 meters per second. Because it's 0 squared plus this square rooted, it's just 49. Now let's find how far. Now I'm going to show you two ways to say how far. How far. So I'm going to start off with the definition of average velocity in the y direction. V average is going to be the change in y, and this is just in the y direction with respect to time. And if I want to find out how far, that is delta y. That's how far it moved. It went from y2 to y0, right? So it went from here, y1 to down here, y2. That is delta y. That's what I want to find. So I know the time interval delta t is 5 seconds. But what's the average velocity? Well, here I could say v average is v1 plus v2 over 2. You can literally just average a velocity if a equals a constant. Okay, so if it's a constant acceleration problem, which is the most of the ones you're going to do, you can just do this. And so remember, I know the initial velocity is 0. I know the final velocity is 49, negative 49. So I can find the average velocity. V average is going to be 0 minus 49 over 2. That's going to be 24.5 meters per second negative. That's right? 49 divided by 2. Yeah, I got it right. Okay. And that's going to be equal to delta y over delta t. I can multiply both sides by delta t. I get delta y is negative 24.5 meters per second times 5 seconds. And I just go over here times 5 equals 122.5. It's actually negative, right? Negative 122.5 meters. That's the displacement. It is a vector. Technically, we would write this as delta r is displacement. And I should spell it right. And I left off the n. So we use r for the position vector. And this is the change in position vector. It is a vector. And so this is the y component of that vector, so we do have a negative sign. Now, how far did it travel? Well, that would just be the magnitude of the displacement. So that's magnitude of delta r. So it's just going to be 122.5 meters. Okay, I told you I would show you another way to find this, right? So we can use the kinematic equation in the y direction. It looks like this. y2, and I'm not going to derive this, okay? y2 equals y1 plus v1, I'll write this as delta t, minus 1/2 g delta t squared. So you may see this with just a t and with an a there instead of a g, but I put in the acceleration is negative g, and technically this is a time interval. So we know the initial velocity, we know g, we know t, we know y1. Well, we don't really know y1, but that's fine. We want to find y2 minus y1. Well, if I subtract y1 from both sides, this just becomes v1 delta t minus 1/2 g delta t squared. Let's put in our values. v1 is 0 times 5 minus 1/2 times 9.8 times 5 squared. Now, we already did the problem. Hopefully we get the same thing. Let's find out. Clear. Put this right here where you can see it. So I'm going to say negative 0.5 times 9.8 times 5 squared. 122.5 meters. So again, this is one of those kinematic equations. If you haven't seen that before, that's fine. I kind of like finding it this way using the average velocity because it kind of makes more sense. You don't have to derive or memorize this equation right here. But, you know, it's the same thing. So we get the same number, and that's how you do that. Hopefully that helps.